Hello friends, welcome to Mathematics Portal. Today we discuss synthetic division or honors scheme. And for this purpose we need some expressions. So first we suppose the division of p and x by the linear expression x minus h. Let qx be the quotient and r be the remainder when p and x divided by x minus h. So you can see that p and x and qx defined here, and p and x is the general polynomial of n degree and qx is the polynomial of n minus 1 degree. So this can be written as like this and this, and from 1 on comparing the coefficients of various powers of x, we find some expressions. We get that a naught equals to b naught, a1 equals to b1 minus b naught h, a2 equals to b2 minus b1 h, an minus 1 equals to bn minus 1 minus bn minus 2h, and finally an equals to r minus bn minus 1h. And this also can be written in the form of b. So b naught equals to a naught, b1 equals to a1 plus b naught h, b2 equals to a2 plus b1h, and finally we got the remainder r, which is equals to an plus bn minus 1h. And conveniently the following scheme known as the synthetic division and honors scheme is used. So you can see that in the first row there are the coefficients of the polynomial p and x. You can see that a0, a1, a2 and so on. And but in the second row you can see that there are the coefficients of the qx, which is multiplied by a h, where h is the term using in the linear expression x minus h. So we can find this scheme by first we write the coefficient of the polynomial a and x in the first row, and by leaving the first place we write the coefficient of the quotient qx by multiplying a h. So you can see that how. First we multiply h to b naught and putting this here. This is the b naught h. On adding a1 to b naught h, we write here, which is equals to b1. Now again multiplying this h to b1, we write here. On adding a2 to b1 plus h, we get that b2. Now again we multiply h to b naught, we write here, and this process will going on up to the n terms. So this is our synthetic division or honors scheme. I will show you by using some examples how this can be used in our problems practically. But first you take a look on the remarks I have pointed out. So first is, if the divisor is of the form x plus h, then we write minus h in place of plus h, and the following process above. And the second point is, if the divisor is of the form ax minus b, so first we write ax minus b in the form like a multiplied by x minus b by a, and then we find the quotient and the remainder of p and x when divided by x minus b by a, then divide the quotient by a, we get the final answer. And now I will show you some examples how this can be used in some our problems. So here is our first example, which is a polynomial of 4 degree and divisor is 3x minus 2. So you can see that here is a 3 multiplied 2x. So first we put into an ideal form. So we take common 3. So we get x minus 2 by 3. Now here is x minus 2 by 3 is in our ideal form. And now we using the honors scheme. So first we write the coefficient of the polynomial. So coefficient of the first term is 1, the coefficient of the second term is minus 4, this is positive 6, this is minus 4, this is minus 1, and h is here 2 by 3. We can write this here on leaving the first place. So we write down 1 here, which is our b naught. This is our b naught. Now multiplying 2 by 3 to this, we got here, and now adding this and this, we get minus 10 by 3, which is our b1. Now multiplying again 2 by 3 to b1, we get minus 20 by 9. Now again adding 6 and minus 20 by 9, we get 34 by 9. Now again we get and this term now adding we get 1 by 81, and this term is look like our remainder. How? I will tell you. Okay, you can see that this is our 4-degree equation and our divisor is of 1 degree. So the quotient should be 3 degree. So we get quotient here, and these are the this and this are the coefficients of the quotient. So we write down the quotient. So we get x to the power 3 and quotient is 1. So there is it is. And the next quotient is minus 10 by 3 x to the power 2. Next coefficient is 34 by 9, and this is the last term, which is constant. So 1, 2, 3 and 4 terms, and our quotient is complete. So this is the remaining term, and this should be our remainder. But you can see that there is a 3 multiplied to x minus 2 by 3, and we find the honors scheme by using this, but 3 is remaining, so we divide this quotient by 3, get the final answer. So on dividing this quotient by 3, we get 1 by 3 x to the power 3 minus 10 by 9 plus 34 by 27x minus 40 by 81. So this is our quotient and this is our remainder.